Today in lesson 3.2, we're learning to define a function. So you are looking at a relation, which a relation is any group of inputs and outputs. But a function is a special group or a special relationship between values. And in this special relationship, each, that's a semicolon, input, which is the x value, has exactly one output, which is that y value. So a relation, they don't have to have a special relationship, but a function is a special relationship. So an example of a function would be if you had, whoa, that brace got a little carried away, a set of ordered pairs, 0, 6, 5, -2, 7, 9, and 11, -1. So that would be a special relationship, a function, because each one of these x's, 0, 5, 7, and 11, all have a different y. They're all going to a different place. However, an example of a not a function is if we had -4, 1, -1, whoops, 7, -1, 2, and 5, 6. So you can see right here that -1 is trying to go to two places. Well, you can't go to two places. So if you think about yourself, you can't be both at home and at school. You can't go to the store and be at the movie theater. You can't do that at the same time. You cannot be in two places at once. And so that's kind of how X's and Y's work. X is like the person and Y is the place that it is going. So that's why for a function to work, each X can only be going to one Y. So we're just going to quickly look through these and talk about, is it a function? Is it not a function? So number one, is number one a function? So what you're wanting to look at is basically, is X listed one time? Do you have any repeating X's? And all of these X's are different. We've got 5, 3, 2, 0, and -1. So yes, this is a function. When you look at the next one, we've got a -2, a 0, a +2, a 3, and a +2. We have two +2's. So that means this is not a function. Or the answer to the question is no. Is the relation a function? No, it is not. On the next one, we've got -4, -3, -2, 1, and -3. We have two -3's. So that means this is not a function. Then for this last one, we've got a 1, a 2, a 3, a 4, a 5. Those are all different. So yes, this is a function. Another way a function can be represented is in a table. So up here we just had a list of ordered pairs. Here we've got some tables. Same thing. You literally do not care about Y. You are just looking at X. And you're asking yourself, is every X different? No. We've got 2 3's, so they are not all different. Okay, here we're going to look at the X's. We've got -4, -2, 1, 2, and 5. Those are all different. So yes, that's a function. On the next one, we've got -5, -3, 0, 1, 2. They're all different. Yes, it's a function. On number 8, we've got 1, 4, -7, 4, and -1. So we have 4 twice, so that is not a function. Over here, now this one, people are like, ooh, I don't like this because all of the y's are the same. I don't care about y. I don't even look at y. Y is not my concern. But all of these x's are different. We've got -8, -4, 0, 4, and 8. All of them are different. So we're good to go. That's a function. And then the last one, of course, they're all different. We've got 1, 2, 3, 4, 5. So that's a function as well. So you are just looking at, are all the x's different? That's what you want. You want the x's to be different. I guess I could capitalize this, huh? That's the question you're asking. Same thing for the table as in the mapping diagram. You're just looking at x. You're not looking at y. Don't look at y at all. In fact, I wish that I could somehow cover this up on my iPad so you couldn't even see it. But you can see here that each x has one arrow coming off of it. It is only going to one place. So yes, this is a function. Now on number 12, 1 is trying to go to 2 places. Or sorry, -1. -1, you can't go to 2 places. You can't go to Grandma's house and Disney World. Grandma doesn't live at Disney World. So this is no. This is not a function. Number 13, all of those x's are only going one place. So this is a function. Now some people get hung up because this 2 has 2 x's coming to it. But guys, we're all at school. So we all can go to the same place. We just can't go to 2 different places. So let's say that, okay, the year Colby was a freshman, that's my son. So I was here. Kaylee was here, that's my daughter. Colby was here, that's my son. And Colby's wife was also here. Her name is Amber. So let's say Colby and I went to school that day. Let's say Kaylee had to go to the doctor and Amber was sick and stayed home. Colby and I can come to school together. We did. So don't let the Y's mess you up. You don't even want the Y's. Don't even look at them. You're just looking at what X is doing. Okay, the next page is the vertical line test. So this is how we determine if a graph is a function. So the vertical line test says if a vertical line looks like this, it's up and down, intersects a graph more than once, then it is not a function. All right, so let's do a couple of examples. So a function, so let's do, here's our y-axis, here's our x-axis, and then we're just going to put just a random line on here. That is a function, because if you took a vertical line, so we're just going to do this, see, it touched it one time. So it is a function. All right, let's do an example of not a function. Y-axis, x-axis, circle. If you take a vertical line through this circle, it touches it 2 times. 1 time here, 1 time here. So it is not a function because you're going to have this x. So let's say this x right here is 4. You've got 4 going up here to 4 and down here to -4. You're trying to send 4 to 2 places at once. You can't do that. Okay, so some examples of this are, we've got a couple of scatter plots. So sometimes scatter plots are functions, sometimes they're not. This one is not a function. And here's why. Because right here, that vertical line touches 2 of those points. So not a function. What about this one? This one is yes, because we can draw an individual line through every one of these points and it only touches 1 point at a time. So that one is a function. All right, well, this is basically like our little example up here. So 16 is yes, and we could draw tons of vertical lines through this. You're never going to touch but one place at a time. See, you're just touching 1 time. All right, this is a sideways parabola, and a sideways parabola is not a function because look what happens. Very first line, touching 2 times, but it's going to do it every vertical line until you get all the way down here. All of these will touch it 2 times, so not a function. We already talked about a circle. Every vertical line that you put through here is going to touch 2 places, so this is not a function. This one is a function because you can put all the vertical lines on it that you want and it only touches the graph 1 time each. So you're good. The next one is a vertical line. The whole thing is a vertical line. So if you put a vertical line on it, you're touching the whole thing. So you're touching tons of points. Actually, let me take this just off so you can see that, but definitely not a function. This one is a function. You can put lots of vertical lines through here, only touching 1 time. It doesn't curve back on itself, so it is a function. All right, so that's all for that video. Your assignment today is going to be in IXL. You're going to have IXL sections. Let me write them over here. Well, IXL sections in Algebra 1, Q.1, Q.4, and Q.5.